All right, continuing our lesson 4.6, we are now going to talk about evaluating a function. So they are giving us that w of x. So that's where this is our function w of x. This is our function notation that we talked about in the beginning of the first video. Anyway, it equals 250x, and this represents the number of words. W of x you can read in x minutes. So W of x is replacing y, and well, why would we do that? Well, in math, a lot of times mathematicians are writing about multiple functions in a paper, and yes, mathematicians do have to write papers, or scientists are using equations within their papers, and so it is easier to refer to functions as w of x, f of x, g of x, h of x, as opposed to all being y equals, y equals, y equals. So this allows it to where we can write functions to look different, and then we'd be able to match them like in an appendix, or like the first time you put it in a paper, you write the whole function, but then from there on out, you refer to it as its function notation. So that's the point of function notation. It really isn't supposed to be there to confuse you. What this does allow us to do is when we write w, instead of just writing y, I'm replacing x with 8. So w of 8, my function at 8, is 250 times 8. And so then w of 8 equals 150 or 250 times 8, which evidently my brain just stopped on me. 2,000 is our answer there. And so what that means is we can type 2,000 words per minute, or WPM for words per minute. That's all that we're doing when we're evaluating a function. It's just we've replaced y with function notation. And in all actuality, it's kind of nice because this gives us our x and our y in one statement. All right, so example 4. The domain of f of x equals negative 1.5x plus 4 is 1, 2, 3, and 4. What is the range? And so, oh, that's great. Take care of that in just a second. The best way to do this is to create a table where I'm plugging in my x's, 1, 2, 3, and 4. I'm going to plug them into the negative 1.5 times x plus 4, and that's going to give me my f of x. And that's where we're going to start this problem. All right, so we're going to plug in negative 1.5 times 1, because I'm plugging 1 in for x, plus 4. And when I plug that into the calculator, I get that my f of x is 2.5. And now I'm going to plug in negative 1 times 2 plus 4. And I end up with 1. And negative 1.5 times 3 plus 4, and we end up with a negative 0.5, and then a negative 1.5 times 4 plus 4, and we end up with a negative 2. So again, all I'm doing is I'm plugging my x values into the equation, and I'm getting my y values, my f of x, my output. So my range, that's our output values, and so the range, not rain, right? The range of this function is negative 2, negative 0.5, 1, and 2.5. That is my range, because I'm just finding the values for each of these domain values. And I plug those domain values, and that's what gives me my range. All right, this is our last last problem for this unit. So we have 3 quarts of paint to paint the trim, so that's probably going to be important information, in our house. A quart of paint covers 100 square feet. The function A of Q equals 100Q, represents the area in square feet that Q quarts of paint covered. So it wants to know what domain and range are reasonable for the function. So let's talk about domain. Domain is our X values. So if we're painting, the least quarts that we could have is 0 quarts. That's the least amount. Now, the most amount of paint would be 3 quarts because that's how much we have. So our domain is going to be that 0, and we're not using X, we're using Q, is less than or equal to Q is less than or equal to 3. That is our domain, because we only have 3 quarts to paint the trim with, and we can't have negative quarts of paint. And so the smallest our X value can be is 0. All right, so then, sorry, hold on just a second. Sorry, the dog was being needy. All right, so now we're going to work on, we're going to work on the range. And so the best way to do range is we're going to plug in these X values, because that range is dependent. Our range is our Y value, which means it is dependent on our X values. And so I'm going to take, and I'm going to find A of 0 equals 100 times 0. So A of 0 is 0. And then I'm going to find A of 3. So that would equal 100 times 3. And so then A of 3 is 300. And so then if I make a table to make my graph, my Q's are going to be 0, 1, 2, and 3. And my A of Q's are going to be 0, 100, 200, 300. And then when I graph it, I'm going to count these by 1. I'm going to go skip 2. So really I'm counting by halves. And then I'm counting by 50s here. So 100, 200, 300. So 0, 0 in the corner, 1, 100, 2, 200, and 3, 300. And to bring back that continuous versus discrete, because we could use less quarts, it's not just these whole numbers, I am going to connect, but I'm not going to draw through the 3 because my graph ends at 3. 3 quarts is the most that we can do. And so our range, because I didn't write this one down, our range is going to be 0 is less than or equal to A of Q, which is less than or equal to 300. So this is our domain. This is our range, and that's a 0, not a D. And then this is our graph. And so those are our reasonable outputs. We can't do anything other than that. And that is all that I have for you. I don't know why it did that. That was a nice little jump. All right. Until next time, 8th graders.